Welcome, geometry students, to the homework help video, page 477, numbers 1 through 20. Let's go ahead and get started. Numbers 1 through 6, we're going to use this diagram right here, and we're going to see if we can state whether these proportions here are true or false. Okay, now, my advice, students, is to draw these triangles, and please watch how I do this and learn, okay? I'm going to draw these triangles separately. Okay, so give me just a second to do that. It'll take about a minute, but I think that's very important to do. Okay, so there's this triangle here, and notice we have a right triangle here, or a right angle there, excuse me, even though it doesn't look like it. We have D right here, C right here, and B right here. Now let me go ahead and trace this triangle here. And we'll slide this triangle right over here. And let's see what we have for this triangle, guys. We have a right angle here. We have D here. We have B here. And we have A here. And then last, I'm going to trace the big triangle, so I can get rid of this picture. And plus, I really don't want to have a triangle with this line here down the middle. So that's why I'm going to trace the big triangle, okay? And now let's slide this out of the way. And it looks like I'll have a right angle here. And let's see, we have A, B, C. So A is here, B is here, and C is here. Now, we do know something. Well, hold on, guys. Listen to me carefully, please. Please watch this. We have learned that when you have a right triangle, like this big right triangle right here, and then we have an altitude drawn from the right angle of the big right triangle, from the right angle to the opposite side, it divides the triangle up into three triangles, a little one, and a big one, and all of these triangles are similar. We learned that, okay? That's a theorem that we learned. I kind of quoted there in the Mike Earhart version, but you get the point, okay? So I can state that all these triangles are similar. So, my suggestion here is to, if I can do this without getting all the other triangles in the way, well, it's going to be hard to do, but anyways, I want to write some triangle similarities here, but first, I better decide which angles are equal, okay? For example, I know that this triangle here and this triangle here share this angle, so I know this angle here has to be congruent to this angle here. Has to be. So there's only one angle left. So that's got to be 2 marks and 2 marks. Now, see this triangle here? Remember, this triangle here fit right in here, okay? So that means that this angle here is shared with this angle here. So if this angle has 2 marks, this angle has 2 marks, there's only one angle left, so it's got to get 1 mark. So now I can state my similarity statements very well. I'm going to start off with this one over here. I'm going to say triangle A, D, B is similar. Now, I start off with A. A has 1 mark, so B has 1 mark. Next is D. D is my right angle, so over here D is my right angle. So B, D, C is similar to, okay, B is first. B has 1 mark. What angle has 1 mark over here? A does. Now, I didn't put the little triangle symbol with all of these, but we know we're dealing with triangles. D is second. That's a right angle. So over here, my right angle is B, and then my last angle not used is C. Do you see that okay, guys? So I'm not sure if I'm going to need all of these again. Maybe I will, maybe I won't. I'm going to go ahead and try to get rid of all of these very quickly here. And maybe I can just save all of this. In case we need it later, okay? Alright, now, so looking at my similar statements, watch what I can do here, guys. Okay, now, using my similar statements here, let's see, I have DB over BC. So DB over BC, that works. We have DB over BC, see it, equals DA, the first 2, over, oh no we don't, they've got it backwards, okay. Boy, guys, this is gonna be really challenging. This will be so good for you guys. Please please watch carefully before I say anything, before I go any further. You see now why it was so important to split my triangle up into 3 triangles, and then you see how important it is to write my triangular similarity statements, because now I can go right through these. Okay, dB over DC. Well, I'm going to use a different color here. Okay, dB over DC. dB over DC equals, and then it says dA. Well, that'd be this here. So dA over dB. That looks really good, guys. dB over DC equals AD over dB. Okay, that's definitely true. That works fine. And so, that would be true. Okay. Alright, let's take a look at our next one here. Actually, get rid of these red lines first. There we go. Okay, number 2. Now, number 2 says BA. Okay, I've got a BA here. BA over BC. Okay, so there we go. BA over BC equals BC over BD. Guys, you can't start with this triangle and then go to this triangle, and then for your second rate, start with this triangle, go to this triangle. Look, if you're going to say AB, oh, by the way, Mr. Earhart, how'd you know it's this AB? Why not this AB? I didn't. I did not know for sure, okay? I was going to try AB first. If this AB hadn't worked, then we've jumped over to this AB, okay? Alright, AB over BC equals, and then it should be BD over BC, and they have BC over BD. Yeah, I don't see that working at all. I'm going to try the other one real quick here. AB over BC. AB over no BC here, no BC. No, that's not going to work at all. That one's totally false, guys. There are no ratios that work like that. Alright, let's try number 3. Alright, AD. Now here's AD right here. Got it? AD over AB. Here's AD. No AB. Here's AB. So I have AD over AB equals AC. Well, there's no AC here, guys. There's no way it can work. I have AD over AB equals AC over AB. There's no AC here. Now, maybe it's a different AD. I can try that. But there's no other AD up here, so no. That's totally false. All right, let's take a look at number 4. CA. Where's CA? Right here. CA over CB. Alright, that's good. Looks good. CA over CB equals CB over DC. Looks totally good. AC over BC equals BC over DC. Yep, looks totally good. That should be true. Hopefully it is. Let's see. Yep, definitely. Alright, moving on to number 5. AC. Here's an AC. AC over AB. Right here. So AC over AB equals AB over AC. No, I don't see an AC over here. Okay. Yeah, that's not going to work, guys. Let's look at it again. AC over AB. AC over AB equals AB over AC. There's no AC over here. I'm going to try another one real quick. AC. Is there another AC anywhere? There's not, is there? So no, that's definitely false. There's no other ratios we can check. Alright, let's take a look at this one. AC over AB. Alright, AC over AB. So AC over AB equals AB over BC. There's no BC over here, guys. Okay, let's look at it again. AC over AB. AC over AB equals AB over AD. It's not AD, it's BC. That is totally not going to work, okay? Alright, let's move on now to number 7. Number 7, find the geometric mean of 4 and 9. Now, you can take the square root of the product of the two numbers. That's one way to do it, and that's totally acceptable. And you'll get the correct answer. Another way to do it is the two numbers that you're trying to find the geometric mean of. You put one on the top of the fraction, put an equal sign, and put the other number in the bottom, and then put an x here and an x here, and then solve. X times x is x squared. 4 times 9 is 36. Take the square root of both sides. The square root of x squared is x, and the square root of 36 is 6. By the way, whenever you're dealing with geometric mean, you always want the positive value, and that is why I did not put positive positive, negative over here. Okay? That's by definition of a geometric mean. Alright, moving on to number 8. Same thing again. Find the geometric mean of 6 and 24. So you can take the square root of the product of these two numbers, which would be what? 144. I didn't check my answer back here, did I? Let's see if I'm right. Should be 6. Okay, good. I think it's 144, and the square root of 144 is 12. That's the fast way to do it. That's a great way to do it. Another way is to take the two numbers that you're finding the geometric mean of, put one of them in the top of a fraction, put the other one in the bottom of a fraction, and then fill in the other two spots with x's. X times x is x squared. 6 times 24 is 144. Take the square root of both sides, and you still get 12. Alright? Okay, number 9. The legs of a right triangle are 9 and 14. How long is the hypotenuse? Now, students, that's going to be Pythagorean's theorem. That's really simple, okay? Look, here's my right triangle. I don't care if it's drawn to scale. One leg is 9 inches. One leg is 14 inches. How do I find the hypotenuse? Well, it'd be leg squared plus leg squared equals hypotenuse squared. Remember, you could only use Pythagorean's theorem on a right triangle. So one leg is 9. The other leg is 14. And the hypotenuse is h. Square the 9, you get an 81. Square the 14, I think you get 196. See? Yes, 196 is correct. Add the two numbers together, and you will get 277. Take the square root of both sides, and because you're dealing with the length of a triangle, you're not going to put plus minus, because the length of a triangle could never be negative. So we're going to take the positive. 277 equals h squared, or excuse me, equals h. I took the square root of this side and the square root of this side. Now if you want to type that into your calculator, you're going to get 16.64. And there we go. Pythagorean's theorem. Number 10. The sides of a triangle are 8, 9, and 12. Is it a right triangle? Well, normally, I encourage you guys to add the two smallest sides together and make sure they're longer than the third side to make sure you have a triangle. But the problem says the sides of a triangle are. So we are given that we have a triangle. So to see if it's a right triangle, we take our two smaller sides, we square them, and we add them together. We take our longest side, we put it over here, and we square it. And let's see if we get the same number on both sides. 8 times 8 is 64. 9 times 9 is 81. Add those together, and we get 145. Alright? 12 squared is 144. Are the two numbers exactly equal? No, they are not. So do we have a right triangle? No. Now let's review for a second. Do I have an acute triangle or an obtuse triangle? Well, whenever this side over here is greater than your right side over here, we have an acute triangle. They didn't ask us to do that, but I'm just telling you. I'm just trying to review. We would have an acute triangle. Alright. Number 11. The directions say decide whether angle A is acute, obtuse, or right. Okay? Angle A. Well, let's go ahead and get a picture of this triangle here. Always helps to do that. Since we're dealing with a certain angle, we gotta be really careful here. A, B, C. AB equals AC. So I'm going to say this side is congruent to this side. So AC is 12. AB is 12. I'm not even slightly trying to, in fact, to show you that I'm not going to draw my triangles to scale. I'm just going to draw all of mine like they're equilateral. I'm just going to draw mine like this. A, B, C. So AB is 12. AC is 12. BC is 22. Is angle A a right angle, an obtuse angle, or an acute angle? Now, first of all, students, please listen to me carefully. What is the longest side we have? 22. So 22 must be across from the largest angle. So one thing I do know is this angle A right here is the biggest angle that I have. Okay? Now, let's see if we have a right triangle, okay? We're going to take your two smallest sides, square them, and add them together. Over here, we're going to square the longest side. Well, we have 144 plus 144. which gives us 288. Alright, now we're going to take 22 and square it, and we're going to get 484. So guys, obviously we do not have a right triangle because the two sides are not equal, okay? The left side is smaller than the right side. That means I have an obtuse triangle, okay? Now if I have an obtuse triangle, that means one of my angles is obtuse, and it has to be the biggest angle. Well, A is my biggest angle, so A has to be my obtuse angle. So angle A is an obtuse angle. Alright, let's take a look at number 12. ABC. AB and AC are 8. BC is 8 square root of 2. Alright, well let's see what happens. Here we go. Let's square our two smaller sides and add them together. And then let's square our longest side. And by the way, how do I know that's the longest side? Well, if you take 8 times the square root of 2, you're going to get 11.3, okay? So this side here is 11.3 approximately. So that is my longest side. That's how I knew that. Now, moving on, 8 times 8 is 64. 8 times 8 is 64. Add those together, and you will get 128. Now take your 8 square root of 2 and square it. So if you square the 8, you get 64. If you square the square root of 2, remember when you square a square root, it's like canceling those out. Just leaves you with the inside, which is 2. So multiply those together, and you get 128. Okay? So yes, they're equal. So yes, we have a right triangle. Now, remember in a right triangle, the longest side is always the hypotenuse. Where's the longest side? I already told this to you guys. Right here. So if that's the hypotenuse, then this has to be the what angle right here? Right angle. So angle A is a right angle. Alright, number 13. AB is 2, BC is 2, AC is 2. They're all 2. Alright? Well, guys, in this case, we know there's no way we're going to have a right triangle. It's impossible. And you might say, Mr. Arrowhead, how do you know that? Because in a right triangle, the hypotenuse has to be the longest side, and all three sides here are congruent. So, here we go. Well, I'm just going to stop and say, why am I going to do all this work? I can't believe I was getting ready to do all this work over here. If all the sides are the same, then I have an equilateral triangle. And we learned months ago that all equilateral triangles are equiangular, and all equiangular triangles are equilateral. So this is equiangular, which means all of the angles have to be what? 60. So what is angle A? Acute. It has to be an acute angle. Okay? That was easy enough. Alright, numbers 14, 15, and 16. They're telling you these three numbers are a Pythagorean triple. Okay? Now, we have to say that's true, or we have to say that's false. Okay, so let's see. Let's take the two smallest sides. And let's square them and add them together. And then over here, we're going to square 313. And let's see if we get out two equal numbers, okay? Here we go. 25 squared is going to give you 625. And 312 squared is going to give you 97,344. Add those two numbers together, and you will get 97,696. Oh no, 969. Alright, now let's take 313 and let's square that. And we're going to get 97,969. So they're equal. So yes, this is true. We do have a Pythagorean triple. Alright. Okay, all right triangles are similar. Well, guys, I mean, look. Think about this for a second. When please listen to me, when any polygons are simple, the angles have to be what? You know, guys, come on. Congruent. And the sides have to be what? Proportional. So, the answer, of course, is there's no way every right triangle is similar. All that I have to do is give one. Hey, what's that word we learned way back at the beginning of the year? All that I have to do is give one counterexample, and I prove it wrong. Okay, remember that word? Alright, here's my counterexample. I have a right triangle, and the angles are 90, 30, and 60. That adds up to 180. Then I have a right triangle over here that's 90, 40, and 50. There. This is a right triangle. This is a right triangle. However, are the three angles of this triangle congruent to the three angles over here? Absolutely not. So there's no way these two triangles can be similar. There's no way. So are all right triangles similar? No. Now, all right triangles have two acute angles. Well, students, that obviously has to be true. Think about it. If you have a right triangle, now come on, think about it. What angle do you have to have? 90 degrees. What do all three angles have to add up to? So I know this angle here, I'll call it X, and this angle here, I'm going to call it Y. I know when you add those two angles together, they have to equal what? 90. So if both angles together have to equal 90, how can one of those angles be 90? The only way one of these angles can be 90 or bigger is if this angle is 0 degrees, which is impossible, or if this angle is negative, like negative 20 degrees, which is impossible. Okay? Well, when you get to trigonometry, we have negative angles, but not yet. But anyways, there is no way these angles here can be 90 or bigger than 90. These two angles in a right triangle will always be acute. That is true. They will always be acute. Okay, let's find the values of X in these triangles. Okay, here we go. Number 17, we have a right triangle and we're missing a leg. So I have leg squared plus leg squared equals hypotenuse squared. 9 plus x squared equals 49. Subtract 9 from both sides. X squared equals 40. Okay? Subtract 9 from both sides. So x equals the square root of 40. Now, listen to me. It's okay for you to type it in. That's called into your calculator. That's called solving it. So one answer will be 6.32. But also on a test or a quiz, I might ask you to simplify it. And if I do, you better be able to do that. Think of all of your perfect squares. So the perfect squares, of course, students, are 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6, 7 times 7, 8 times 8, 9 times 9, 10 times 10, and 4 goes into 40 10 times. So really, 40 is the same thing as 4 times 10. And which one of these two numbers do I know the square root of? 4. Take the square root of 4 and put a 2 on the outside, and you're left with 2 square root of 10. Either one of those two answers would be acceptable, okay? Alright, number 18. It looks like we're missing an angle. Now, students, we don't know for sure that we have a right triangle, so we better check it to make sure. So I take my smaller side and my other smaller side, and I square both of them, okay? And I'm going to see if they equal 18 squared. Well, when you square 12, you get 144. When you square this right here, square the 6, you get 36, times square the square root of 5, and you get 5. So I really have 144 plus 180, okay? Because 36 times 5 is 180. Now when you add these together, you're going to get 324, okay? Now with my calculator, I'm going to type in 18 squared, and I'm going to get 324. So I do know that I have a right triangle. I know that this is my longest side out of all three. So I know the longest, the largest, I know this has to be my hypotenuse, which means this has to be my right angle. So x is 90 degrees, alright? Moving on to number 19. Okay, we're missing a hypotenuse. So I know that because here's my right angle pointing to my hypotenuse. So one leg is 6. My other leg is 12 square root of 2. And my hypotenuse is x. Square 6, we get 36. Square this whole thing, well, 12. Square the 12, you get 144. Times the square root of 2 is 2. So we get 36 plus 288. If you add those together, you will get 4. Carry your 1, 2 carry your 1. 324 equals x squared. Now, take the square root of both sides, and we will get 18. By the way, I did that in my head because the last problem showed me that 18 squared is 324. So if I take the square root of 324, I'm going to get 18. So x equals 18. Okay? And then lastly, number 20. Alright, we're missing an angle again now. This might be a right angle, it might not be, okay? There's a mark here and a mark here. So I know this side is 7, this side is 7. This side right here, if you take 7 times the square root of 2, you're going to get 9.8. So this is my longer side right here. So I'm going to take my two smaller sides, and I'm going to see if we have a right triangle. So I'm going to square my two smaller sides. Over here I'm going to square my longest side. 7 square root of 2 squared. Square the 7, you get a 49. Square the 7, you get a 49. Add those together and you get 98. Now over here we square the 7, that's 49. You square the square root of 2, that gives you 2. Multiply those together and you do get 98. So I know that I have a right triangle. I know this is my longest side, thus this is my hypotenuse. And if this is my hypotenuse, then the angle directly across has to be 90 degrees. So that angle is 90 degrees. Okay? Guys, I hope this mid-chapter review homework help video has been a help to you. If you have any questions, don't hesitate to call or email.